So, Chapter 8 deals with value types, reference types, typecasting, which we've looked at before, and memory use. And these are all somewhat related, which is why they're all in the same chapter. The two areas of memory where variables are stored are called the stack and the heap. The data type of the variable typically determines whether it goes into the stack or whether it goes into the heap. And we're going to talk a little bit about the differences between the stack and the heap in a few minutes. But data types that store values in the stack are called value types. And the data types that store values in the heap are called reference types. So we're going to take a look at the different data types that we have been working with, and we will be identifying whether they are value types or reference types. So primitives are built-in data types, like integer and double and float and character, etc. And they can be used to create other data types. So when we use lists or arrays or array lists, we actually specify these primitives as being part of our list or array list or an array. Okay, so we use these primitives when we're creating these other data types. Primitive values store data in the stack. And a lot of the data types that we use are considered primitive. So when a value is stored in a variable, the system allocates memory to that variable based on the data type. And we've taken a look at the size of different data types back at the beginning of this book. We can access the value stored using the variable name. Each time a variable is created, it is stored in a different memory location. So it's always helpful to see a graphic of how this all works. And so in this graphic, we have an integer variable called number, and it is going to store the number 10. So what happens when we create this variable? Well, it goes into a part of memory called the stack. You just learned that. And this part of memory that is storing the number 10 has a memory address. Okay, and that is part of random access memory, also called RAM. And in memory, the memory address looks kind of strange, but this is an example of what you might see if you actually were looking at a memory address. Okay, so this is the memory address where the value 10 is stored, and this is the variable that created it. All value types in C# come from a class named value types. Kind of makes sense. The value types class is related to the system object class. And the system object class supports all classes in the .NET class hierarchy. So what is the difference between a value type and a reference type? Well, one difference, even though you're not quite sure what reference types are yet, but one difference that you already know is that reference types are stored in a different area of memory. So, unlike value types, a reference type doesn't store its value directly. Okay, so what does that mean? Well, if we look here, when we create number 10, it is stored here and it has a memory address. Okay, and so this is what we are referring to as it's stored directly, right? We can get right at it. We don't have to look anywhere else. Reference type is a little bit different because it's not going to store the value that way. What it does is it stores an address that basically directs it to the location where the value is actually stored. Okay, and it is stored in an area of memory called the heap. Okay, so when you are working with a reference type and you create a variable with a value, the area of memory that it accesses is not where that value is actually being stored. What it is storing is a pointer to another area of memory where the value is stored. Okay, so it's basically referring you to another storage location, hence the name reference type. Okay, and what types of variables are reference types? Strings, arrays, classes, which we will be working with in the next chapter, delegates, and interfaces. Delegates and interfaces we don't get into until next semester. Okay, but you guys have already worked with strings and you've already worked with arrays. Also, the collections are in heap memory, so they are all reference types. So lists, array lists, and there are numerous other collections. Those are all considered reference types. And so basically all that means is that the variable is actually storing a memory address. And when it goes to the memory address, it actually points to another location of memory where the actual value is being stored. So it's referring you to a different location. And then you might think, well, that doesn't really sound very efficient. It actually does let you utilize more of memory because there's a lot of memory use that leaves kind of gaps in space. So there's open space. And so this lets you take advantage of space that isn't being used. And, it might not be right next to each other. So the heap is designed to store values in non-contiguous memory locations. And that just means that the memory locations are not right next to each other. Okay, and that's why we need a pointer. Okay, so we have variable s that is directing us to this location. And then when we look at what's stored, it's actually directing us to another memory location that is large enough to actually hold the data that we have entered. So at this point, you guys know that the computer is going to look at our data type, and then it's going to assign values to memory based on the type of data that we are using. The stack and the heap have different capacities, and the values that we put in them have different lifespans. And a lifespan for a variable is just how long that variable exists. So the stack is designed to store temporary variables. So any variable that is created in a method, and when you exit the method, it is destroyed, that will be stored in stack memory. Any variable that is created within a block, and then you exit out of the block, and it is destroyed, that is also in stack memory. So stack memory is basically for temporary variables. The stack is faster than the heap because when a value is stored in the stack, there is no pointer to a different location. So, when you access that variable, you can directly access the value it is storing. It doesn't point to a new location that you have to look up. So retrieving data from the stack is a lot faster, but the size is limited. So the size of variables that you put in the stack have to be fixed. You can't put lists or array lists or any collection in the stack because they are dynamic in size. Okay, and anything that goes into the stack has to have a fixed size because the amount of memory is limited. Also, because the amount of memory is limited, the stack cannot store as much data as the heap. So what is the advantage of using the heap then? Well, the heap does not have a size limitation because it doesn't use contiguous memory. It uses non-contiguous memory, so it can take advantage of free space on the disk or in memory. So it utilizes pointers to basically reference where different parts of a variable are stored. So retrieving the data involves following the pointers to retrieve, the different parts of a string or the different parts of a list or whatever you happen to be storing. And that can make retrieving data a little bit slower. The heap is used to store global variables. Global variables are ones that are declared above a class. So they are known to all of the methods in the class, and they retain their value. Um, it also stores any dynamic type, and it stores all reference variables. And to help out, I actually did a little graphic here. Just, because graphics are kind of a nice way to remember things. So value types that are in the stack would be primitives, which we already discussed what those were. Enums, which you have not learned about yet, and it will be next semester before we talk about those. Structures we will also cover next semester, but I did list some of the primitive types down here. Reference types go in the heap. So we've got class, interface, which we'll talk about next semester, array, string, and delegate, which we will also talk about next semester. In addition, and I didn't put this in here, but all of our collections are in the heap as well. So why is all of this important? Well, there's a number of reasons why it is important, because where the value is stored affects the lifespan of a value, and reference variables, uh, they exist for the life of the program. So, and they have a couple other unique qualities. And one of the differences is what happens when you pass values to a method. So the type of variable is actually going to determine how the variable is passed. Values that are stored in the stack, so those are all your primitives, those are passed to methods call by value, which basically means a copy is sent to the method. So if you change the value in the method, you have to return the new value to main or wherever you called that method from, and you have to store it or you lose it. Okay, and so that is call by value. You're not actually sending the real value. You are sending a copy. Okay, and so we have examples. So this little example illustrates what happens when you pass something call by value. Um, and you can copy and paste it right into Visual Studio and run it. But you can see we have a number set to 10, and we are passing that number to a method called ChangeMe. And here we bring the number in, okay, and we change it to 20, and we're returning the new number, but we are not storing that new value. And so the number in our main method is not going to be changed. Okay, so it will not change it because when we pass number, it is passing a copy. It's not actually passing the memory address for this value. It's passing a copy. And so we get the copy in here and we change the copy. And if we don't save it when we get back up here, it's gone. That new value is going to be gone. So when it writes this out, what it's going to print is 10 because we didn't bother saving it. Okay, so then we come down here and we call ChangeMe again. So this time when we call, okay, it's still going to send a copy, and we are still changing it to 20 and returning the new value. But you can see that we are now storing that new value in number. So this is going to change the value that is being stored in main. Okay, so when we print it out here, it is going to print out 20. Okay, so when you are passing a value type and it is modified in a method, you have to save it when control returns from that method. Okay, or the change is going to be lost. Okay, and you can see the results from that printout. So call by reference is a little different because call by reference, you are not passing a copy. You are passing the actual address and value. So what that means is when a method changes the value, that change is permanent. Okay, you are not changing a copy, you are changing the real thing. And we will take a look at that. So here we have another example, and we have a little integer array, and it's got 4 numbers in it, and we print out those original numbers, and we pass the entire array to a method called changeme. So we come down in here, and you'll notice that it's not returning anything, and we're bringing in the array, and we are looping through, and we are multiplying each of these numbers by 10. And then we return. Because an array is a reference type, when we called changeme and we passed number, it was not a copy. It was this array. So when we change the numbers, it's changing these numbers. So when we return and we print it out, it's going to print out this array with the new numbers, because arrays are reference types and it does not pass a copy. Okay, so you can see here's the original numbers, and then here's from that second printout. Now, one thing that is important to note, if we pass one element, so instead of passing this whole thing, what if we just pass one? Okay, what if we index in and we pass, let's say, if you can see this, what if we do something like this, change me number 0. Well, now we're not passing an array anymore. We are just passing one element. We are passing the number 10, and that is going to pass as a value, not as a reference. So it's going to pass a copy. We only pass the reference when it is the whole thing. Okay, so that is one little thing that you are going to have to remember, that when you pass one element, it is treated as a value type. The whole array is a reference type. So you might be thinking, well, this is really very inconvenient. What if I wanted to pass, a primitive as a reference? Is there any way that I can do that? Yes, there is. There happens to be a couple of keywords that you can use that will tell C# that it should be passing it as a reference, and it will pass the actual value instead of a copy. The advantage of passing that way is that you could pass several variables and you can update them. Because normally in a method, if you're passing a value type and you update, you can only return one thing. This would allow you to update several variables without having to return them. And probably my best example that I think a lot of you will relate to is maybe a method call to a game method where you need to update a character's lives, their energy, and their health. Okay? And normally passing these variables, they would be passed as value types, and it would pass copies, which would be a problem because you'd be changing them and you could not pass all three of them back. So if we pass them as reference types, then the method can make changes to them and we don't have to pass anything back. So to pass them as reference types, all you have to do is put the keyword ref in front of the variable, or you have to put the keyword out in front of the variable. And you have to do that in the method call. And you have to also do that in the method signature, which is the first line of the method. Okay, and the main difference between out and ref is that out requires variables to be initialized and ref does not. Okay, so that is the primary difference. Which one is better? I mean, you could use either one. It's actually easier for me to remember ref if I want to send it as a reference type, because that just makes perfect sense to me. But you could use either one. But whatever one you use, you have to remember to use that down in the method signature as well. So we're going to take a look at a program or a couple examples here of passing values as reference variables. So this one is using the keyword out. And so here, this is pretty much the same example that we looked at earlier, where we have a variable called number, okay? And this is a value type. However, when we call change me, we put the keyword out in front and it is passing it as a reference. Okay, so it comes down here into the method. We have the keyword out. And so it is pulling it in as a reference, which means that when we change this value, we actually don't have to return anything. Okay, because changing the value here is also going to change it up here. Okay, so we put it in here, and you can see that even though it's returning, we are not storing what's being returned because we don't need to. And when it prints out the value of number, it will be 20. Okay, and you can see that it was 20, and you can copy and paste this and run it yourself and see that that works. This is the exact same thing using the keyword ref instead of out, and the results are the exact same. Okay, two different ways to do it. The difference is that out requires that you initialize the value before you pass it. This example shows what happens when a single element from an array is passed with ref and without ref. And remember, when a single element is passed, by default, that is passed call by value. So a copy of it is passed, not the actual value that's stored in the array. So here we've got our number array. And here we are passing, we're indexing in at 1. So we're passing it number 20. And we've got ref in here. So this is being passed as a reference. Okay, so when we come down here, it's going to go into this one. It's being brought in as a reference. And you'll notice that the integer is not an array here, right? Because when we pass 1, it is not being passed as an array. It's being passed as a single value. Okay. So here we've got ref integer, and we're going to call it n. We actually change it to 500. because it's a reference, we really don't need to return anything. We're not storing what's being returned because we are going to have that change because we are passing it as a reference. So once we return, our array is going to have 10, 500, 30, and 40. Okay, and then we come down here and you'll see for this one, we are not passing it as a reference. So we're calling change me again, coming in here. This one is not bringing in a reference. It's trying to change the value to 200 and it's returning the value, but unfortunately we are not storing that value. Okay, so when we run through the for each and it prints out what is in this array, it's going to be 10, 500, 30, and 40. It is not going to keep that change that we made down here because it was not passed as a reference. Okay, it came in here as any integer would. Okay, and when we returned, we did not store the change. Okay, and so you can see that it did not keep that 200 value. Now, we've talked about typecasting before, and so this is a little review, but there is two ways value can be typecasted. There is something called implicit casting, and that happens when the compiler does it automatically in order to perform arithmetic. And it will automatically convert a smaller data type into a larger one. This is called a promotion, and it'll do it because there's no risk of losing data. Okay, so you can go from character to integer, you can go from integer to long, long to float, float to double, not a problem. Okay, it is a problem if you want to do the reverse. If you want to go from a larger data type to a smaller data type, there is a risk of losing data, and C# will not do that automatically. Okay, and so if you want to do something like that, you need to do explicit casting. And this is where you are telling the compiler the data type that you want to convert it to. And the way that you tell it is that you put parentheses around the variable. So let's say, oh, I've got double salary equal 500. And let's say I have int average salary equals, and let's say I'm going to divide by 10 or something like that. So I could do this. Okay, I could temporarily convert salary to an integer and divide it by 10. Okay, when I do this, that is an explicit cast because I'm telling C#, I want this to be an integer. And because it started out as a double, there's a risk that you're going to lose data. In this case, I wouldn't because I didn't have anything in my decimal section. But if I did have something like that, I would lose data because it would convert it into an integer and I would lose the whole decimal portion. Okay, so an explicit cast is one that the programmer puts in. Implicit is one that C# will automatically do. And we've got some examples. And these are all examples of implicit conversions, which is something that C# would do automatically. There is a danger when you explicitly cast. And so I want to point that out. I do have an example, and this is what an explicit cast would look like. You'd go from integer to short. Short is a smaller data type. Long to either integer or short. So you're going from a bigger data type to a smaller data type. And if you're dealing with calculations, there's actually two different ways that you could choose to do the cast. And I'm going to show you an example because the way that you put in the explicit cast actually affects the results. So here I've got a number with a fairly large number of digits in the decimal. And so here you can see I want my result to be an integer. And instead of converting this to an integer, I'm actually doing the math and converting the result into an integer, which I then store. Okay, so that is one way of doing a typecast. Okay, you kind of convert the result of the arithmetic into the data type that you're going to store. The other way of doing it is to convert each piece. So I could do the typecast in front of this number on the top, and I could do a separate typecast in front of the number on the bottom. Okay, and doing the typecasting these two different ways dramatically affects the results. So the first equation, okay, where I do the typecast on the result of the math, I get 1219. The second equation, where I do a typecast on each part, I get the value 1234. That is a pretty big difference. Okay, and then what happens if I do it without any typecasting? Well, if I just do the arithmetic, okay, this is the actual result. So you can see that the first technique of letting it do the equation and then doing the typecasting is more accurate than this second method. And so that's why you want to be a little careful if you are doing typecasting. Boxing and unboxing. Typecasting involves converting values from one type into another, and boxing and unboxing is very similar. What boxing does is it converts a value type into an object. And unboxing does the opposite. It converts an object into a value type. So depending on what you're doing in your program, a programmer may want to have values stored in the stack or in the heap. And the way that they are going to accomplish that is they're either going to box or unbox because objects are stored in one place and values are stored in the other. Okay, so that might be one reason to box or unbox. Boxing a value type will copy it to the heap, and unboxing an object will copy the value into the stack. And remember, the stack is temporary, but the heap, values in the heap remain there for the duration of the program. So how do you box or unbox? So boxing converts a value type like an integer or double into an object. And this happens when a variable is assigned to an object. So here we are going to create our value type. Right? So this is just a regular old integer. And then to convert this into an object, we would use an object actually is a valid data type, but any data type that creates a reference type could be used. So you're going to have your data type here, and then this would be your object. And we get into classes next week, so you're going to be creating a lot of objects. But you'll have your class or whatever data type here. You're going to have your object name here. You set that equal to the variable, the primitive variable that you want to convert. And that is really all you need to do to convert it. So once it's converted, this is how we'll refer to it. We're going to call it my object and not my number. Okay, but my object is going to have the value 10 in it. Okay, it's just that my number is going to be stored in the stack, and the number 10 that's stored in my object is stored in the heap. So boxing is fairly simple, right? We just take any of our primitives and we assign it to an object. Unboxing involves taking your object and doing an explicit cast on it and then assigning it to a primitive type. Okay, so here we've got an object with the number 10. So that is being stored in the heap. And we do a typecast on it, an explicit typecast. And then we store it in an integer. Okay, and that goes in the stack. Okay, so unboxing is going to be explicit because we have to have that typecast in there. And I have some examples here as well. If it decides to load, there it is. So for this one, we've got a list, and my list is an object. Yeah, you see we've got a lot of numbers in there. And then we have another object called value. And then let's see. Here we've got a var item in my list. And we take item and we store that in value. Value is an object. And then we are using object equals to check to see if it has a value of 30. So if we were to play computer first time through, it's going to have a 10. Is 10 equal to 30? And then it's going to do objects.equals, passing the 10, passing the value we're comparing to, which is 30, and that returns false. Goes through again, grabs 25. Is 25 equal to 30? No, false. Get this one. Is 30 equal to 30? Going to return true, and so on. So the reason that we are doing the little unboxing business here is so that we can actually use this method. And let's see what we've got going on here. Okay, so we have a list of objects that we're running through a for loop. Each value retrieved in the loop is converted to an integer to perform arithmetic to determine if it's even or odd. Okay, so we have my list. got a bunch of numbers, and we're going to go through it one item at a time. And here we are doing that little explicit conversion into an integer. So we can tell if it's even, and then we print out it's even, or we print out it's odd. Okay, so that is everything that you guys need to know about memory use, value types, reference types, and how to change types.